In this video, I'm going to continue looking at zeros, multiplicity, and graphing our polynomials. So I'm going to look at one where it is in factored format, and then I'm going to look at one in which it is in standard format. So let's first look at let's just look at if I have g of x is equal to a negative 3 times x minus 2 to the third times an x plus 1 squared times an x minus 4 squared. So in this case, it is in factored format. Everything is multiplied together. So I have this term, here's another term, here's a term, and here's a term. So I have 4 different terms. But if you notice, my first term does not have an x value in it. It does tell me what my leading coefficient is, though. My leading coefficient is going to be this negative here. For my degree, I'm going to look at the terms with a variable, which are these 3 terms here. And this term has a degree of 3, this one has 2, and this one has 2. So that gives me a total degree of 7, because remember, I'm going to add up those exponents. Since I am negative, the end behavior is going to be down on the right-hand side because it's negative. And since it is odd, it means that I'm going up on the left-hand side. Remember, odd means that I'm going in opposite directions. So now that I've found the end behavior and everything, I want to look at the zeros and their multiplicity. So I'm going to take each of my terms and set them equal to 0. Now, when I say each of my terms, each of my factors, I want just the factors with a variable. Because if I set negative 3 equal to 0, negative 3 is not ever equal to 0. So that one's not even possible. So I'm going to set x minus 2 equal to 0, x plus 1 equal to 0, and x minus 4 equal to 0. And I'll solve each of these. So I'm going to add 2 to both sides. And so that I get x is equal to 2, I'll subtract a 1 from both sides. So I get x is equal to a negative 1. And then I'll add 4 to both sides. So x is equal to 4. So if I look at this now, I'm going to look at the multiplicity. So this first one, x minus 2, came from here, and so its multiplicity is a 3. So if it has an odd multiplicity, think about what we learned in the last video. Is this going to touch or is this going to cross? And hopefully you remember that it will cross. Now, with x equaling negative 1, that is this term, it will have a multiplicity of 2. So if we have an even multiplicity, that means that it will touch. And x minus 4, so x equal to 4, is this one. It also has a multiplicity of 2, which is again going to touch. So I'm going to see if I can put me in a graph again. Okay, I'm going to enlarge it just a little bit. And I'm going to look at first my zeros. So I have a 0 at 2. I have a 0 at -1. And I have a 0 at 4. I'm going to scroll up and look at my end behaviors here. My end behaviors said that they were going in opposite directions. So that means that this one should be going down, and over on the left-hand side is going up. And so I'm going to come to my first x-intercept, which is -1, and I'm going to look back at its multiplicity, which tells me to touch, which means I'm going to go back up. I'm going to come back to the x equal to 2. That one tells me multiplicity of 3, which tells me I'm going to cross. I'm going to go up to 4, which it has multiplicity of 2, which tells me to touch. And I'm going to go back down, and I will end. So on these, what we're looking at is, are we touching? Are we crossing? What's our end behaviors? So now I want to do one in which the function is not already in factored format. So let's look at g of x is equal to an x to the third minus a 5x squared minus 16x plus 80. Whenever things are not already in factored format and we have something with a larger exponent, a lot of the times we are going to have to factor. And this particular one, we can actually factor by grouping. We have 4 terms. In later sections, we will look at how to do it if there's more than terms than that, okay? But in this one, we have 4 terms. So I'm going to group my first 2 terms. And so I'm going to look at those 2 and say, what can I factor out of those? Well, looking at those, there's not a number, but I can factor out an x squared. And that will, if I take out an x squared here, that will leave me with an x. I take out an x squared here, that will leave me with a -5. Then I'm going to look at my second set of terms. And when I'm looking at those, I want to find, is there a number that will divide into both of them? Remember, I always take this sign here, so it's a negative. And in this particular case, my greatest common factor for those 2 is actually going to be a -16. So I'm going to take a -16 out, which will leave me with an x. Positive 80 divided by a -16 will leave me with a -5. I am then going to see if my parentheses are the same, which they are. So I get x minus 5 times an x squared minus 16. Now at this point, I can actually go ahead and say 0 is equal to an x minus 5 times an x squared minus 16. And I'm going to set each of those factors equal to 0. So I get x minus 5 is equal to 0, and x squared minus 16 is equal to 0. And I'm going to solve each one of those. So I add 5 to both sides. So I get that x is equal to 5. Now on the second one, the first thing I'm going to do is I'm going to add 16 to both sides, which will give me an x squared is equal to a positive 16. Now be careful on this one. I want to take the square root of both sides, and wherever I do that, I have to get a positive and a negative. So I actually get that x is equal to a positive and -4. So I actually have 3 different x-intercepts or zeros. I have x is equal to 5, x is equal to a positive 4, and x is equal to a -4. And with each one of these all occurred one time because none of them had multiplicity or anything of that nature. Okay? Now, going back to this top part here, I want to find my degree, which since this one is in standard format, I just look at my largest exponent, which in this case is 3. Then I look for my leading coefficient, positive or negative. So my leading coefficient is going to be positive. So if it's an odd degree, that means that I'm going opposite directions. And a positive means I'm going up on the right-hand side. So I'm going opposite directions here. Now, one thing that I didn't talk about before, and I'm going to scroll up and look at the previous one, was notice if I look at these multiplicities, a 3, a 2, and a 2, the multiplicities should add up to my degree. So in this case, 3 plus 2 plus 2 does give me that 7, which is my total degree. On this one down here, if I think about multiplicities for each one of those, they're equal to 1. And if I add up how many multiplicities I have, that is my final degree of 3 as well. So let's look at what this one would look like when we graph it. So my zeros are at 5, 4, and -4. So I have a 5, a 4, and a -4. My end behaviors were opposite directions with it going up on the right-hand side. All of my multiplicities were 1 or odd, so that meant we crossed. So I'm going to start over here on the left-hand side, come to my first x-intercept, and I'm going to cross. I'm going to come down. I'm going to hit my next x-intercept. I'm going to cross. And I started out the wrong way. I apologize. I don't know why I started on the top right. I'm sorry, top left. I should have started on the bottom left. Come up, cross, 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 and go. That is totally my fault. I apologize. So I want you to practice graphing some of these polynomials. And then in the next section, we will look at what happens whenever we have larger degrees in standard format.